Dear students, welcome again to the class of Business Mathematics, and this is Lecture 2, Part 1. And today's topic is linear equation and linear function. So the first question is, what is a linear equation? So to understand linear equation, you first need to understand what is an equation and what is degree of an equation, because linear equation also known as first degree equation. So what is an equation? If two algebraic expressions are connected by the sign of equality, let's say ax plus b equal to c. So here ax plus b is an algebraic expression and c is an algebraic expression. So if two algebraic expressions are connected by the sign of equality, then this statement is called an equation. And the degree of an equation is the highest power of the variable. Here x is a variable and it has power 1. So the degree of this equation is equal to 1. And let us consider another equation, ax square plus bx plus c equals 0. And here a, b, c are real constants and x is the variable. The power of x is 1 and 2. So the highest power is 2. Therefore, the degree of this equation is equal to 2. So the degree of an equation is the highest power of the variable. And a linear equation is a first degree equation. So the definition can be like that. An equation having degree 1 is called a linear equation. In other way, we can also define a linear equation in this way. An equation of this form, ax plus b equal to c, is a linear equation in one variable x, because here x is a variable and a, b, c are real constants. And again, we can an equation of the form ax plus by equal to c. This is also a linear equation or first degree equation. However, the number of variables here are 2. So this equation is a linear equation in two variables x and y, and a, b, c are real constants. So linear equation can be one variable ax plus b equal to c or 0, and can be two variable ax plus by equal to c, or can be of three variables ax plus by plus cz equal to d, and so on. But here in this course, our equation in linear equation in two variables will be important, because we want to relate a linear equation with the linear function. And the standard equation for the business school, a standard linear equation in two variables will be this. This is the general form of a linear equation in two variables, or standard form y equal mx plus c, where x is a variable, y is a variable, m and c are real constants. And note that if you sketch or graph a linear equation, then it will always be a straight line. So the graph of a linear equation will always be a straight line. However, if you graph a quadratic equation, then it will be either concave down or concave up for an equation having degree 2. And if you graph a cubic equation, then it will be like this. If you graph a biquadratic equation or fourth degree equation, then the graph will be like this. So you can here note that the fourth degree, this is the corresponding equation of this graph will be fourth degree, and the corresponding equation of this graph will be third degree, and the corresponding equation of this graph will be of second degree. And when the equation will be of fourth degree, then in the graph you will see three peaks. When it is 3 degree, then you will get 2 peaks. When it is second degree, you will get only 1 peak. When it is first degree, you will get there is no peak. You will just find a straight line. So the graph of a linear equation will be a straight line. Now let me say it again. An equation of the form y equal to mx plus c is the general form of an equation of a straight line. So we can say that this is the general form of an equation of a straight line. General form of an equation of a straight line. And here the coefficient of x is the slope of the straight line or gradient of the straight line, and c is the y-intercept of the line. The constant term c is the y-intercept of the line. And I will explain the definition of slope and y-intercept of the line later. But now let us relate linear equation with the linear function. But before that, let us have a look here in some example. Example 1, in this line y equal to 3x plus 8, this is an equation of a straight line having slope 3, because we know slope is the coefficient of x, and y-intercept is 8. Y-intercept means what is the y-intercept? Let me say it here. If a line is like this, then this is the y-intercept. Y অক্ষের খণ্ডিত অংশ. This is the y-axis, and this is the x-axis. This is the line y equal to mx plus c. So this line has slope m and y-intercept c. So y-intercept is the distance from origin to the point where the line cut at y-axis, and this distance means y অক্ষের খণ্ডিত অংশ, and this distance is the x-intercept of this line, which means x অক্ষের খণ্ডিত অংশ. So this is the x-intercept. So for this line, y-intercept is 8, because the constant term is the y-intercept. And I will tell you how can we calculate x-intercept later. And in this example, the gradient or slope of this line is -3 and y-intercept -8. And in this line, the slope will be -3/5 and y-intercept will be 3, because you need to convert this line to the standard form. So let us see how can we do that. We can write 5y equal -3x plus 15. So if I want to, let me convert it to the standard form. Dividing both sides by 5, we have -3/5x plus 3. So this line has slope -3/5 and y-intercept 3. Now let us try to understand what is a linear function. A linear function will be again the equation. I said linear equation. Now I am saying that it's a linear function. But an equation, a linear equation in one variable, ax plus b equal to c, this cannot be a linear function because there is a single variable. A linear equation to be a function, there must be at least two variables. If a linear equation will be of like this, let's say y equal to ax plus bz plus c. So this is a linear function of, here y is a linear function of x and z, and here in this equation y is a linear function of x. So a linear equation in two or more variables, you can say a linear function. So now let us try to understand a linear function. A linear equation of this form, y equal to mx plus c, is called a linear function of y in terms of x if for any single value of x there is a single value of y. In other way, we can also say that if two real variables x and y are so related that for a single value of x there is a single value of y, then we say y is a function of x, and we write y equal f of x. It means y is a function of x. And for this equation I can say y is a function of x and z, y equal to f of x and z. And here you see y depends on x. For example, let's say y equal 2x plus 7. So here if x equals 0, then y will be 7. If x equal to 1, y will be 9. If x equal to 2, y will be 11. So y depends on x. Therefore, x is an independent variable. X is called an independent variable and y is called a dependent variable. In other words, we can also say that x is an input variable and y is an output variable. So what is a function? A function is a mathematical rule. Let me say it again. A function, let us consider a function like this, y equal to 2x plus 7. So it's just a mathematical tool where each input, single input has single output. An input variable is x, output variable is y. If x equals 0, if you input 0 with this machine, then the output will be 7. If your input is 1, then the output will be 9. If your input is 2, then the output will be 11. So a function is a mathematical tool where a single input has a single output. You can also define a linear function like this. However, you see, if your machine is something like this, y square equal to x, then if your input is 4, then output will be what? From here we can write y equal plus minus root 4. If the input is 4, so y will be plus minus 2. So for a single input there is two output, plus 2 and minus 2. So this is not a function. We cannot say y is a function of x, but it's a relation. This is called relation. So now let us define the slope of a straight line. Note that if you know 2 points on the straight line, let's say first point x1, y1 and second one x2, y2, then the slope m will be rise by run. So the slope of a straight line is the ratio between rise and run. This is the change in x, and change in x is the run, because at this point x equal x2 and at this point x equal x1. So this change in x will be x2 minus x1, and at this point y means y2 and at this point y means y1. So the change in y will be y2 minus y1. So the change in x is the rise, which is also denoted by delta y, and change in x is the run, which is also denoted by delta x, and delta y means change in y coordinates, change of y coordinates, y2 minus y1 divided by x2 minus x1. So this one we can use as a formula. If you know 2 points on the line, then you can calculate slope of that line, x2 minus x1. By using this formula, we can calculate slope of a given line. And there are other two important formula to get an equation of a line. If you know slope on the line and a single point on the line, if you are given slope and a point on the line, then by using this formula, you can calculate equation of a line. Let's say an equation having slope 2 and passes through 5, 7. An equation of a line having slope 2 and passes through 5, 7 will be y minus y1, and y1 means 7 equal m into x minus x1 means 5. So this implies y equal to x minus 10 plus 7. This implies y equal to x minus 3. So this equation is the required equation having slope 2 or gradient 2 and passes through 5, 7. And again, if you know 2 points on the line, then directly you can use this formula, x minus x1 divided by x1 minus x2 equal y minus y1 divided by y1 minus y2. Let's say you know an equation passes through 2 points 2, 7 and 5, let's say 5, 10 or 5, 11, 2, 7 and 5, 11. Then the equation of that line will be x minus x1. You can consider 2x1 or 5 as x1, but let me consider 2 as x1. 2x minus x1 divided by x1 minus x2 is 5 is equal y minus y1 is 7 and y1 minus y2 is 11. So this implies x minus 2 divided by minus 3, which is equal y minus 7 divided by minus 4. You can cancel minus and minus. Now this implies y 3 into y minus 7 by cross multiplication equal 4x minus 8. So this implies y minus 7 is equal 4 by 3x minus 8 by 3. Dividing both sides by 3, this implies y equal 4 by 3x minus 8 by 3 plus 7, which implies y equal 4 by 3x and what is that, 8 by 7 minus 8 by 3, which is equal 21 minus 8, which is equal 13 by 3. So this equal plus 13 by 3. So this is the required equation of a line which passes through 2, 7 and 5, 11. However, if you think that the formula 2 is complicated for you, then by using formula 1 you can also find the equation of this line, which passes through 2, 7 and 5, 11. And in that case, you first need to calculate m. So m will be y2 minus y1 divided by x2 minus x1, which is equal 4 by 3. Now you know m, and you can consider 2, 7 as x1, y1. Now you can use first formula, y minus y1 equal m into x minus x1. So this implies y minus y1. y1 is 7 is equal 4 by 3 into x minus x1 is 2. So this implies y equal 4 by 3x minus 8 by 3 plus 7. This implies y equal 4 by 3x plus 13 by 3. So now you can compare this result and your previous result. Both of them is same. So they are same result. Therefore, you can even by using only the first formula, you can calculate equation of any line. Now the definition of parallel straight lines. Two lines we know are said to be parallel if they maintain equidistant from each other. Always these lines are parallel. And again, two lines are perpendicular if the angle between them is 90 degree. These lines are perpendicular because their angle is 90 degree. Two straight lines are said to be parallel if their slopes are equal. Two straight lines having equal slopes is said to be equal. Let's say this line has slope m1 and this line has slope m2. Since they are parallel, their slopes will be equal. m1 will be equal to m2. For example, y equal to 5x plus 7 and y equal to 5x plus 12, they are parallel lines because their slopes equal. Slopes of these lines are equal. And the next definition is perpendicular line. Two lines are said to be perpendicular if the product of their slopes is equal to -1. For example, this line and this line, if perpendicular, then the product of their slopes will be -1. And there is another example, y equal to 5x plus 7 and y equal to -1 by 5x plus 12. These lines are perpendicular because the product of their slopes will be -1. You see 5 into -1 by 5, which is equal -1. And these lines are also perpendicular. And y-intercept, I said before in this equation, y equal to mx plus c, c is the y-intercept. But there is another way, you can also calculate y-intercept. To calculate y-intercept, you need to put x equal to 0 in the equation. So if you put x equal to 0 in this equation, you will see, you will get y equal to c. So c is the y-intercept. And again, to calculate x-intercept, you need to put y equal to 0 in the line. So if we put y equal to 0 in this line, we will get mx plus c. So therefore c equal x equal minus c by m. So minus c by m is the x-intercept. For example, let us consider this line, y equal to 3x plus 8. If we put x equal to 0 in this line, then we will get y-intercept, which is 8. And if we put y equal to 0 in the line, then we will get x equal to minus 8 by 3. And minus 8 by 3 is the x-intercept. And similarly, you can check this one and this one by itself. So now let us solve two problems, and those problems will be related to parallel and perpendicular lines. So let me read it. find the equation of the line through 2, 7 and parallel to this line. Since the required equation is parallel to this line, so the required equation will be of same slope. Slope will be again 1.5. The required equation will be of slope 1/5. So now we can use this formula, y minus y1 equal m into x minus x1 to get the required equation. You see, y minus y1 equal m into x minus x1, and here y1 means 7, x1 means 2, and slope 1.5. Therefore this is the equation. This is the required equation. And let's say find the equation of a line through origin. Let me delete it. Instead of this I said through origin and parallel to this line. Then what will be the equation of the line? Just instead of y1 I should write 0, and instead of x1 I should write 0, because we know origin means 0, 0. The coordinate of origin is 0, 0. So x1 will be 0, y1 will be 0, and the required equation will be y equal to 1.5x. Now let us try to understand another example. Find the equation of the line through -2, -6 and perpendicular to this line. So the required line will be slope of -3, because their product, the product of their slope should be -1. In other way, you can also calculate. Let's say m1, m2 is equal to -1. So m1 is given 1/3, and you need to calculate m2, which will be equal to -3. So now your m2, it means the slope of the required line is -3, and required line passes through -2, -6. So you can use this formula, the same formula, y minus y1. y1 means -6 and x1 means -2. So y minus y1 equal m into x minus x1. Therefore y plus 6 equal -3, -3x plus 2, so -6. Therefore y equal to -3x plus 12 with the required line. Now the last problem in this lecture is this problem. Let me read the question first. Plant A is in existence at a point 5, 6. So plant A is located at 5, 6, and 5, this is the origin. This point is the origin, and this is our x-axis. This is the y-axis. So 5, 6, how we get 5, 6? If we count from here, 1, 2, 3, 4, 5, x coordinate 5 and y coordinate 6. 1, 2, 3, 4, 5, 6. So this is the location of plant A, and a new plant B is to be located on the x-axis, and the new plant B is on the x-axis. So let us put these things in our mind. At a point such that the connecting line, there is a connecting line of plant A and B that is perpendicular to the straight line. The connecting line is a straight line that is passes through 0, 5 and 8, 0. So this is the line. Let's say 0, 5, 8, 0 is this point. Let's say this point, the coordinate, let us denote this point by C, and let us denote again this point by D. So the question tells us AB is perpendicular to the line CD. So therefore you first need to draw CD, then from A you need to draw a perpendicular line, and this line cut at x-axis at this point. This line cut the x-axis at this point, and this is the location of plant B, because it says a new plant B is located on the x-axis. Now we need to know the location of plan B. Find the coordinate of the location of plan B. And again we know that the coordinate of y on the x-axis is 0. So the y coordinate of this point will be 0 and x coordinate we need to calculate. And let's say x coordinate is x. So here line AB and CD are perpendicular. Therefore we can calculate the slope of AB first and then slope of CD, and since they are perpendicular, so the product of their slopes will be -1. So slope of AB will be, let's say M1 is the slope of AB, slope of AB is M1, which is y2 minus y1 divided by x2 minus x1, and slope of CD, let's say this is M2, which is y2 let's say 5 minus y1 0, and x2 minus x1 0 minus 8, which is equal minus 5 by 8. So since they are perpendicular, we can write m1 into m2 equal to -1. It means 6 by 5 minus x into minus 5 by 8 equal to -1. So let us compare it here. 6 by 5 minus x, or it can be 6 by 5 minus x, and so on. Let me do it here. So this implies minus 30 divided by 5 into 8, which is 40, minus 8x equal to -1. You can cancel minus and minus. Therefore 30 is equal 40 minus 8x, or 8x is equal 40 minus 30, which is 10. Therefore x equal 10 by 8, which is equal 5 by 4. So you see the result is same, x equal to 5 by 4. Therefore the location of plan B is 5 by 4 0. The coordinate of B 5 by 4 0. If the length of the axis is in miles, let's say the length of this axis is in miles, 1 mile, 2 mile, 3 mile, 4 mile, and so on. So 4 by 5 mile, 5 by 4 mile 0 is the location of plan B, and 5 by 4 miles means 1.25 miles. So we can say that the position of the plan B is located 1.25 miles to the right from the origin, to the right from the origin. So that's the result. Or you can finish your answer here. According to this question, it says find the coordinate of the location of plan B. So that should be the end of the solution of this question. The coordinate of the location of plan B is 5 by 4, 0. So that's all in this lecture, and in our next lecture I will discuss the application of linear equation or linear function, which is known as cost equation or cost function. So thank you for your listening.